This is the problem number 15, which is given matrix C, we need to find out the eigenvalues of C, which is either A, B, C or D. You can pause the video for some time and try to solve the question. Now moving on to the solution. If we see this matrix C, then we see that row 1 and row 3 are same, row 2 and row 4 are same. Then if we apply these two operations and then interchange row 1 and row 2, then we will get this matrix C. If we carefully look this matrix, this is nothing but row reduced echelon form of C. Since there are two rows in row reduced echelon form of two zero rows, since there are two zero rows in row reduced echelon form, which means that the nullity of matrix C is 2, and we know that nullity of matrix C is equal to number of zero rows in row reduced echelon form, which is also equal to number of zero eigenvalues. Since the nullity is 2, it means the number of zero eigenvalues of matrix C is 2. That is, two eigenvalues of C are 0. Let's say lambda 1 and lambda 2 are 0. And now to find the remaining eigenvalues, one way is to find the roots of this characteristic equation. Okay, but to find the root of to find the determinant of C minus lambda I for a 4 cross 4 matrix is very time consuming. Okay, now I am going to tell you one of the shortcut to find the eigenvalues. So for any square matrix, if sum of each row is same, then this 1 1 1 1 1 dot 1 1 1 transpose is an eigenvector of that matrix corresponding to eigenvalue, which is equal to sum of that each row. What does that mean is, let a matrix A such that sum of each row is A, is small a, and x be an vector of n dimension. Then what we will get, if let's say this is a matrix A and this is x, then multiplying A with x, what we will get is, multiplying this with this is A1 plus A2 plus an, which is equal to sum of this row, which is nothing but A, because sum of each row is A. Similarly, they will get b1 plus b2 plus bn, which is also equal to A. Okay, if we take A as common, then we will get a 1 1 1 1 dot 1, which means A into x is equals to small a into x. This we will get. This is nothing but this is the eigenvalue equation of matrix A. Okay, which means x is an eigenvector of A corresponding to eigenvalue A. A is an eigenvalue and this x will be an eigenvector of A. Okay, here we will see this matrix C. Here sum of each row is 2. Each row is 2, and hence 1 1 1 1 will be an eigenvector of C corresponding to eigenvalue equal to sum of each row, which is 2. Hence one of the eigenvalue is 2. Now if we see trace of, which is sum of diagonal element, trace is 0, which means sum of eigenvalues are 0. This is 0, this is 0, the lambda 3 is 2, hence lambda 4 we will get is minus 2. Hence option B is correct. Thank you.